Today I am going to explain about the interface that is 4x4 keyboard and that is display on the LCD board. Okay, that is like first of all, why we supposed to display the LCD? Because like whatever we supposed to enter the keywords and special character or it may be numbers. Okay, that has to be visible at the user side. So with the from the LCD kit. Okay, here basically we supposed to learn how the fundamental connections activity it is going to taken place between the ARM LCD to ARM LCD display and ARM controller, that is microcontroller 2148 kit. Okay, see then only we can easily understand the program, okay, how it is going to display or how the transaction happens between the LCD kit and the LCD display. Okay, see this is the pin connections for the keypad and LCD of the our LPC 2148. Here I have taken the number of columns and number of rows. Okay, along with that I am going to use for 8 data lines. Okay, that I am going to connect it from the LCD display kit to our ARM controller board, that is LPC 2148 ARM controller board. Okay, means whatever the data, okay, it is going to display on the LCD kit. Okay, that is that is it is going to retrieve from the ARM controller board, then only it is going to display as the output on the LCD display, so that all the data it is going to interconnect it to our LPC 2148. Okay, then here like before that our RS register, okay, that is nothing but register selection pin and enable pin. Okay, that is always be make it as a high, then only we can visible the our output on the LCD kit. After that I've told, right, I am going to use number of columns and number of rows. Okay, here why I am going to means how many number of columns and how many number of rows I am going to use in this LCD kit, LCD display means I am going to use for the 4 number of columns and 4 number of rows. Okay, because like this is the program, okay, I have written that is 4x4 keypad, so that I am going to use 4 number of columns and 4 number of rows. Okay, based on the program I have taken like this. Here like which are the input and which are the output, okay, that is very important. Here I am going to taken as a columns as the input and rows as the output. Okay, then like we will see like what are the columns, like columns that like I have told, right, that are the input. Okay, that input, okay, which are the port numbers and which are the pins it is going to access the input from the LPC 2148 ARM controller board. Here I am going to use 2 port, that is 1 minute I'll show this. I am going to use for basically 2 ports, that is general purpose input output port to 0 and GPIO port to 1 slow interface. Okay, our ARM controller based on these port, means these 2 port only it is going to work on. As per the program I have taken the port 1 address here. I am going to use the port number 1, the pin number 18, 19, 20, 21. Okay, I am going to repeat port number 1, on that port number 1, pin number 18, 19, 20, 21. Okay, these 4 are I am going to consider as the input pin. The second one is the output pins are again port number 1, the pin number 21, 22, 23, 24 and 25 are the output pins. Okay, now you got it, right, which are the output pins and which are the port we are supposed to use the for the taking transaction. So this is the like fundamental connections happens between the LCD and LPC 2148 ARM controller board. Now we are going to move on to the program. See, this is the diagram of our keypad. Okay, how the keypad will be looks like, and how the connections activity taken place be between the ARM controller board as well as the our LCD display along with the keypad. See, this is the figure of that. Okay, like as per the pictorial representation. Okay, they have represented these are the ports, means they have taken the port 0. Okay, port 0 and port 1. Okay, 2 they have given. See, this is the what. Okay, they have already make the connections between the ARM controller and keypad. See, same thing they have taken here also four inputs. Okay, some of the port numbers, and again 4 columns, like some of the port numbers. Okay, along with that again they have taken as a enable register and RS selection register, and like all the data, means like all the 8 data lines. So this is what the program. The program here, that is #include lpc214.h. Okay, this is nothing but our lpc2148.h is like it is going to like store the address of our ARM controller. Okay, what is the lpc2148? Okay, it is nothing but our ARM controller board address. Okay, that I am going to give it here, because why? Because all the ARM controller board, it is going to taken care all the input output operation, and it is going to process all the transaction. Okay, which we are going to expecting that output from the LCD. Okay, everything it is going to taken care our ARM controller board. So that I am going to give the address to in this header file. This header file, what it is going to do in the program, the #include lpc2148.h, it is going to carry, or it is going to store all the input value, output value, and like others value, means like apart from that output. Okay, it is show like anything else, means okay, everything it is going to include this header file. Okay, I am going to assigning the here local variable as well as the global variable. See, out of the function, what I'm going to assigning, those all are the global variable. Like inside the function, okay, what and all I'm going to assign, that all the local variable. See, I'm going to declaring the functions here, that is what is that, numbers. Okay, unsigned character numbers, and I'm going to use for buffer variable, temporary variable, as well as the key values, and so on. So okay, see, this is what character I supposed to display on the display kit, that is ABCD, some of the characters and values, numbers. Okay, all those things I am going to display on the our LCD display. Okay, then I am going to move on to the main program. See, my control will be starts from int main function. Here the int main function, I'm going to use three selection pin. Okay, that is nothing but I am going to use 3 alternative function. Okay, these already I have discussed in last video. Alternative function 1, alternative function 2, alternative function 3, which is nothing but pin selection 0, pin selection 1, and pin selection 2. Okay, these 3 are the alternative function. Okay, it is going to write the command register to display the output onto the LCD display. Okay, here see, I have along with that I am going to use the IO directions. Okay, I am going to use here two IO directions register. Okay, that is input output directions register. Okay, what it's supposed to do means, it is going to setting the path, or it is going to setting the bit pattern. Okay, like what are all pins it is going to enable during the output time. So it is going to tell about the direction of that particular bit pattern. The bit pattern here, it is going to contain all the 32 bit pattern. Okay, within that it is going to display the value, or characters or number, everything. Okay, then I am going to use the clear function. Why I am going to use the clear function means, okay, one after the other value. Okay, when I am going to display, okay, it is going to clear it, means which is nothing but, suppose I am going to display on the LCD kit for number or the decimal number 8. Okay, it is going to display the 8 on the LCD display. after some amount of delay or some amount of time, it is going to clear that value, then it is going to give the priority to the next value to display on the our LCD display. Means it is not store the previous value along with the current value. So that I am going to use the clear function here. Here the clear function I am going to make it as a FFF. The FF is nothing but in hexadecimal, okay, it is showing F. Okay, in decimal the F is nothing but 111, means 000. Yes, here see, this is the hexadecimal value, okay, that is 000 111 111 111 again followed by 0, means that is our port number 25, 24, 23, 21 and 22 are the port output port address, okay, that it is going to making as a enable always. Okay, when it is going to clear function will it is going to happen, during that time all the pins it is going to hide. Okay, then I am going to display on the command register as well as the data register. Okay, before that, why I am going to use the 4x4 keyboard display on the LCD. Whatever the key we use to press, that it is going to display on the LCD display. Okay, it is not simple, it is not simply going to display, okay, whatever I am going to display onto the LCD display. See, based on the ASCII value it is going to display. Suppose I am going to send some of the characters, that is ABCD, okay, it is it won't display as it is on the display, LCD display. So it is going to send the some ASCII code into the ARM controller. That ARM controller it is going to change that particular value into the hexadecimal. After that it is going to display onto the our LCD display. Okay, then our LCD display, okay, we want to display, like I told, all the numbers or characters or something. During that time it is going to take care some of the matrix method, means that is nothing but 4x4 matrix method. Okay, see, you look at this program I am showing here, that is all the column, like column 1 to 4 I am going to connect it to pin number 18 to pin number 21 at the port 1 for respectively, and the row input also same thing, that is row 1 to row 4, okay, that it is going to the keypad it is going to connect it to pin number 22 into pin number 25 at the port number 1 respectively. Okay, whatever we supposed to explain or whatever we supposed to display onto the our display board, okay, with the help of some delay function it is going to display on it here. Here again the get key function or declaration function I am using while loop here. The while loop, why I am going to use here, means there is no any error inside this function. Okay, means there is no any error, it is going to easily display the output onto the display board, means these all the function, it should be a correct function. So that I am going to give while 1. Okay, there is no any error here inside. Here see, I am going to use for the IO pin 1 and IO pin 1 here. The IO pin 1, when it is going to 1 means that is the 3C here. See, look at this 3C. Thus the value of C will be 12. Okay, because C they have given the hexadecimal value. Okay, the value of 3C here, C is 12. The particular 3-bit it is going to high, and then along with the C value, that is 12, means 8421 coding 8 means 1100. That when that particular 3 and C bit will be high, it is going to display the one of the character. Okay, that is nothing but our E value. See, the E value, it is nothing but, what is the E value here? 14. Okay, I am going to display the 14 here. Then after that again D, that is 13, B is 11 and 7. Okay, like that I am going to keep on displaying one by one value as per the our ASCII code. Okay, so this is what my program has the LCD display onto the key code by using the keypad. Okay, How the functions will be transaction, I told, right, based on the ASCII value. Okay, that ASCII value, it is going to scan our keyboard. That keyboard, it is going to send all the data into our ARM controller. That ARM controller, it is going to fetch the port address. Okay, that is port 1 or port 2. Okay, what and all port pins we have already given into the program. That based on that port address, it is going to display all the values onto our display board. So this is the basic and fundamental connections happens inside the program. Thank you.